Hello everyone. Welcome back to my channel, Monica Math Class. I know it's been a long time, but the topic which we are going to start today is in great demand. This is on the request of my students. So let's get started. Don't forget to like and subscribe my channel. And this topic is also part of number system. Now, can you guess what it could be? So let's see which will be now. So here we go. This is exponents and powers. You all study all type of number systems in your class. Integers, whole numbers, fractions, decimals. But this one, exponent and power, sometimes you find difficulty. Yeah? So we will see that what type of numbers are they and how do we simplify them? Okay? So you can refer to your friends and relatives and come back and see it again and again, how much you want to see it. So these numbers look like, if you can see in my presentation, these numbers look like these. And where 2 raised to the power 5. But the point is, where do we use such kind of numbers? When you have very large numbers and when you have very, very small numbers, like the distance of Earth to any other planet. That's very large. And there are a lot of zeros involved in it. It's not convenient to write all the number of zeros or you remember all the number of all the zeros which are written. So we have devised a plan. Our mathematicians has devised a new number form that is called exponents. Now, I'll give you a little bit introduction so that you remember it. You have seen how these numbers look like, but today you're going to see the rules as well of these. Okay, so in many countries, exponents are also called as indices. So exponents, powers, indices, these are all synonyms. These are the same name. These are the same thing. Okay, and it's a part of number system, as I said. It is also repeated multiplication. Okay, and a number multiplied by itself. So when I see these 2 points over here, a number multiplied by itself, suppose when I say 2 raised to the power 3, so it means that 2 is multiplied by itself 3 times. It means this, okay? Then afterwards, how it looked like? So 2 raised to the power 4, that means we are reading like this and we are writing like this, okay? Next, what do we call base and exponents? So here 2 is called the base and 4 is called the exponent. Similarly, here in the above example, 3 is called exponent and 2 is called the base. So these are the 2 things which you should know initially. So there's a special name given to the powers also. So when you have like 2 raised to the power 3, like if you take this one, so 3 is the power or exponent. This is called cube, okay? 2 cubed. How do we read it as? Sometimes we read it as 2 cubed. If you have 3 raised to the power 2, we say 3 squared, okay? Or 3 raised to the power 2. So these 2 names, especially the powers, when you have, 2 or 3, then we call it as a square uncubed. Otherwise, we say 2 raised to the power 5, 2 raised to the power 6. Okay, so there's a special name. So why we call them as a square and cube? Because they're actually related to square and cube. So like there's another example, 5 raised to the power exponent 2. So it is called 5 squared. Or if I write 5 raised to the power 3, then it is called 5 cubed. Okay. So they are actually related to the area of a square, as I said, and the volume of cube. Like in area of a square, you have side into side, right? So all of this in area of a square, you write side into side. And sometimes, from your lower classes, you're writing s square. So it is actually linked with it. You are doing it subconsciously, okay, before that. And volume of cube, when you write, it is L side into side into side or L into L into L. So when I write like that, it means that L is multiplied by itself 3 times as L cubed. So there the length, breadth, and height are equal. So your square, cube are already related to what you were doing, okay? So let's move ahead. I think this is clear. So now you have this kind of, this is a part of number system, you have this number. But how do we simplify when you have to add these numbers, when you have to multiply these numbers, divide these numbers? There must be some special rules to do it, like you have for some other different number part of system. So we have product rule, we have quotient rule, we have power of a power rule, we have power of a product rule. So we have different rules. So today we are going to see slowly and gradually what do they mean and what are the proof of it, okay? And then later on, we will see some questions based on these rules. How do we simplify them? So let's get started. Yeah. And as I always said, don't forget to enjoy your learning. This is actually easy. When I said it is easy, this is made for you only. So children, let's get started with this. So everybody, if you see the pattern, there is a pattern written. X raised to the power 0 is 1. Then x raised to the power 1 is x. Then we have x square as x into x. X cube is x into x into x. And x raised to the power minus 1, it becomes 1 upon x. So there is, a kind of pattern. So you need to understand how it is. So anything in exponents, okay, a raised to the power 0, it is always 1. So anything, its power 0, it becomes 1. Whether x, whether I see a number 10 raised to the power 0, it is always 1. And I'll show you the proof also why it is 1. Okay. And when you have like x raised to the power 1, okay, the power is 1, it means it's simply x. When you have x square means x into x. So you have to follow that this pattern, that how it is coming up. Suppose sometimes when you have negative exponent, to make it positive, it becomes the reciprocal, it becomes 1 upon x. And if it becomes x raised to the power minus 2, it becomes 1 upon x squared. So it goes on and on like that. So initially understand the pattern. Now, I'll show you the proof of it. So suppose if I say power of a power rule, okay, here x raised to the power m, and then outside there's another power n. That means we multiply the powers. We multiply the exponents. Now, how do we prove this? So suppose if I have this and already, if I follow the rule, it is I have to multiply the exponent. So the answer is x raised to the power 6. And the proof for this is, suppose if I write x raised to the power 3, I'm showing you the proof now. What does it mean? It means that x raised to the power 2 should be multiplied by itself 3 times. So I'm going to write like that. Yeah. And further, when I break this, x square means x into x. Again, x square means x into x. Again, x raised to the power square means x into x. How many x's you have? You can count 1, 2, 3, 4, 5, 6. So you got x raised to the power how many times? 6. So instead of you remember and you do such a big proof of it, you should remember one rule. When you have a power of power, you multiply the powers. That's it. So you get the answer. Instead of simplify so many number of times and breaking into smaller and smaller parts. That's the best fit to do it. Now, similarly, if you have this one, x raised to the power 2 and minus of 3, okay? So when you do it, your answer is x raised to the power minus 6 as per this, okay, power of power. But how do we make it a positive one? So how to make it a positive one? You can write on the reciprocal of it. That's the answer. Yeah. So when you have x, if you want to know the proof, look it here. So minus 3. As I told you that to make it positive, you have to write like this. 1 upon x square into, sometimes, in algebra, we don't write multiplication sign. We write dot. And dot also means multiplication, because then it's very confusing between x and multiplication symbol. So you just write like that. And then you can, simply further simplify and see how many times 2's have come. 2, 2, and 2, it becomes x raised to the power 6. That's the same answer like we have written already. I think you've understood. So any question comes in when you have a power inside and outside, you multiply the powers and it's done. You don't have to simplify it further and further. Next. Now we have a question where you have bases same. As I told you, x is the base and power is m and n. You add the powers. When bases are same and powers are different, I'm writing, just remember it. So when bases are same and powers are different. And this is a product rule, okay? And powers are different in multiplication. Then in the answer, you add the powers. Then the result is add the powers. And how do we do that? So just understand. Suppose if I given you one example, 2 raised to the power 3 into 2 raised to the power 5. What does it mean? Okay, let's see the proof. 2 raised to the power 3 means I will be writing 2 3 times. It means this only. And 2 raised to the power 5 means I will be writing 2 how many times? 5 times. So 3 times here and then 5 times here. Now you have to count how many 2's we have altogether. 1, 2, 3, 4, 5, 6, 7, 8. 2 raised to the power 8. Why don't we simply just add the powers? 3 plus 5. That also means 2 raised to the power 8. Instead of doing this big step, huge step, you simplify. Okay, it looks easy, but in numbers, when you have lots of operations together, in that you are not writing into, because sometimes in your exam, your teacher will ask you that simplify these exponents, these questions using exponents rule. Then that time you will not be writing 2 into 2 into 2. Okay, so when you have a product, so you will be following product rule, add the powers. These type of numbers are very important because you are going to use it in mensuration, in algebra, in trigonometry, in higher classes, in lot many ways. So if you do not solidify this number system, then there's a lot of problem. Okay, so we will go slowly and slowly. So right now we have discussed only two. One is power of power rule, and the second is your product rule, where we add the powers. Now let's see the next one. This is division rule. Okay, we divide the powers, and it's very easy to remember. When you multiply two numbers to get the result, to get the product, you add, right? And in division, you subtract to get the result. Similarly, in exponents, you subtract the powers. Okay, so let's take one example of it. Suppose if I say 3 raised to the power 10 divided by 3 raised to the power 6, what it is? What does it mean? It means that 3 raised to the power 10, I'm showing you the proof, okay? But we will follow the rule only to simplify. So 3 raised to the power 10 means I have to write 3 how many times? 10 times. So write it. Okay, just count 1, 2, 3, 4, 5. So 5 written, 5 more. Then you go, so 1, 2, 3, 4, 5, and one more. So it becomes 3 raised to the power 10 over here. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, 10. Divided by 3 raised to the power 6. 1, 2, 3, 4, 5, 6. So difficult to write so many times, yeah? So now what do? We can cancel in division. So you can divide all these three with all these three. So what is left in the numerator? So it is 3 into 3 into 3 into 3. How many threes are left? 3 raised to the power 4. And that's your answer. So instead of you do this, why don't we just subtract the powers? That's much more easier. So always you'll get the same answer, yeah? So 3 raised to the power 10 divided by 3 raised to the power 6. And most important, this division rule only we are going to apply where you have same base and different powers. Okay. So 3 raised to the power 10 minus 6, even then you get the same answer. So I will advise each one of you to remember the rules. Okay. Next. Now, what it is? Let's do a recap. You have same base. Now, these two are highlighted in yellow. It means that this is same base. Now, when you have same base and different powers, and this dot means multiplication, what do we follow? We will follow multiplication rule. And what is the multiplication rule? What is the product rule? You add the powers. So 2 raised to the power 3 plus 4, 2 raised to the power 7. That's the answer. Okay, that's right. So always remember. Next, we have another rule where we have two. One, the product where your bases are different but power is same. So we separate them, and in both the cases. So for example, if I say 2 into 6 and raised to the power 7, then you can separate it. You can, there must be some, somewhere in the demand where you need to separate. So 2 raised to the power 7 into 6 raised to the power 7. That's how you do it. Understand? They both have the same powers. Here, these two numbers are in multiplication inside. And you just simplify the brackets, you can say it. You're separating them. Then we have 2 upon, I would say 7 raised to the power 3. Then in that case, it becomes 2 raised to the power 3 upon 7 raised to the power 3. Okay, that's how. So that's how you are going to separate it. Whatever the need is, according to the question, you're going to do it. Next, we are going to see how to simplify the questions, and there are some large numbers, how to write them in expanded form. So there are a lot more to do. So, but before that, I want each one of you revise again all the laws of exponents before we start with the later part of its simplification. So happy learning and keep practicing. Rise and shine, Monica. See you soon. Bye.